Hello, this is a thinking and communication problem. We need to find range of k for real solutions in the given equation. Now here, consider the quadratic function kx minus 8 equals to 2x squared. Find the range of values of k. K can have many different values in the domain of real numbers, for which the quadratic function will have one solution, two solutions, or no solutions, correct? So that is the whole problem. So what should we do? One, we should write this equation in more familiar way so that we can understand what real equation is, right? Now we'll bring all the terms to one side and then write it as a quadratic function, right? So I can write this as, I can write it here itself for the time being 2x squared. So I think this implies we can write this as 2x squared minus kx plus 8 equals to 0, correct? So that is our equation. Now if we compare this equation with ax squared plus bx plus c, then what is our a going to be? Let me write here. So a is equals to 2, correct? And b in this case will be equals to minus 8. And c is going to be 8. Oh, b is k minus k, sorry. B is k, b is minus k, and c is equal to plus 8, right? Let me write this equation again. For the equation 2x squared minus kx plus 8 equals to 0, right? That's our equation. To find the real solutions, we need to find what the discriminant is, right? You remember discriminant is what? Discriminant we can write as b squared minus 4ac, correct? And that's our b, this is a, and this is c. So let's figure it out how much b squared minus 4ac is. So for this particular equation, b is minus k. So this will be minus k whole square minus 4 times a is 2 and c is plus 8, right? So discriminant is, this becomes k as positive, right? K squared and 4 times 2, 8, 8 times 8, 64, right? Minus 64. Now, by analyzing this discriminant, we can find out whether we have 0 solutions, 1 solutions, or 2 solutions, correct? Now, if you remember, if this is 0, then we have how many solutions? We have just 1 solution. And if this is positive, then we have how many solutions? 2 solutions. And if this is negative, we have no solutions at all. So these are the 3 conditions which we need to test for, correct? So let's first test for k equals to 0, discriminant equals to 0, okay? So let's say d equals to 0, correct? That means what? That means k squared minus 64 equals to 0, or k equals to, we'll take 64 and then square root, correct? Okay, so let me write k squared equals 64 and k equals to plus minus square root of 64, which gives k equals to plus minus 8, right? So if k is plus minus 8, then we have how many solutions? Just 1, because that will make the discriminant 0. So that gives us condition for 1 solution, right? Now how about 2 or none? For 2 or none, we should have b squared minus 4ac greater than or equal to 0, right? So let's solve it as an inequality here, okay? Let me do it here, okay? So what we are trying to do is, we are trying to see whether it's positive or negative. So what we will do is, we will kind of draw it or graph it on the number line. I'll show you how. Now we have discriminant, let me use different ink here. We have discriminant equals to k squared minus 64, right? So k squared minus 64 can be written as k plus 8 times k minus 8. Does it make sense? Difference of squares. This is a perfect square, right? 8 squared. Do you see that? We got the roots. K plus 8 and k minus 8, right? So on a number line, you will see that at minus 8 and at plus 8, we'll have zeros for this function, for discriminant, right? Plus 8, where this is 0. and it is like going up. Do you see that? So this function is actually kind of like this. What am I drawing? I am drawing d, okay, this function as a function of k, discriminant as a function of k, correct? Now here you will observe that a part of it is negative. Do you see this negative part? Right? So this is when the discriminant is negative. So therefore in that region discriminant is negative, and so we will have how many solutions? None. Do you understand? So that is the region where we have no solutions. So here we have no solutions. So we have no solutions for which type? Let's have a closer look, right? We have no solutions for k greater than -8 and less than 8. Do you understand? At 8 and -8, we have already only one solution. But if k is between these two values, then we say the discriminant is negative, and therefore there are no solutions. But if it is beyond these values, so I can represent this no solution is as like this, between points 8 and -8, but not including them. Do you understand? Between -8 and +8, right? Not including them. And for two solutions, let me just continue here under this if it makes more sense. So for two real solutions, what do we have? We have region beyond this. Do you see that? So we will have the same number line, if it makes sense to again draw it, but you know, this side it is like this. Do you understand? So here it is 8 and this is -8, and that gives you two real solutions. Therefore we have two real solutions if k is less than -8 and or if k is greater than 8. In this case we have two solutions. Do you understand? So we can summarize our result as one real solution if k equals to plus or minus 8. Does it make sense? And two real solutions if what happens to k for two real solutions? If k is less than -8 or k is greater than 8, right? Beyond this region. And we have no solution, no real solution, okay? If k is between -8 and +8, correct? This problem is extremely interesting, and I've seen many times this problem being asked in the test. So have a good look at it, try to understand the concept. Once you understand this, I think you'll be able to solve most of the problems dealing with number of real solutions, okay? Now here is a question for you, but take it as an assignment, okay? So now here the question number 2 is, determine the range of values that k can take for the number of zeros to be none, 1 or 2 for this given function, right? So do you see the function? Fx equals to k minus 1 x square minus 2kx plus k plus 1, correct? I've given the answer here also, but don't concentrate on the answer at present, correct? See the problem. Now here, how are you going to do? You have to follow exactly the same process which we did just now. What is the a value here? A is k minus 1 for you, correct? And what is b for you? B is minus 2k, okay? And what is c? C is k plus 1. Do you see? This is c. Do you understand? And this is b, correct? And this is a. Do you understand? So these are your a, b, and c. So discriminant will be b square minus 4 times this and this. After that, simplify it. Once you simplify, you will get a value and then the answer. Well, now let's discuss the answer. Let's say you do all that and then you get some answer, right? Here is the answer. The answer is like kind of funny. The answer is you get only 2 zeros for this, for all conditions, for all real numbers except for when k is not equal to 1. Now the question is, all real numbers it is 2 zeros, but why we are excluding this value of 1? This is another communication problem for you, okay? Think over it. Let me give you the answer now. The answer is that if I put k equals to 1, then what happens to your equation? If k is 1, then the leading coefficient becomes 0 and the equation becomes just linear. It is no more a quadratic equation. Do you understand? It's no more a quadratic equation, right? Therefore, because we are dealing in the set of quadratic functions, right? So it doesn't really belong to that. Therefore, we are putting this restriction of k not equal to 1. If k is 1, then it becomes a straight line, right? And which is minus 2x plus 2, right? And that will have always one real solution, correct? So those are the answers for you, correct? Okay, I think you understand, and let's move on to the other questions on the same topic.